Hi everyone, welcome back to my geometry videos. In this tutorial I want to go over regular polygons. A regular polygon is both equilateral and equiangular, so in other words all the sides of a regular polygon are congruent to each other, and all of the angles of a regular polygon are congruent to each other. A square is an example of a regular polygon. A non-square rhombus is not a regular polygon since not all angles are congruent to each other, even though all sides are congruent. So let's show how that works. So we have square ABC. So all the sides of the square are going to be congruent. So the square is equilateral, and all the angles are going to measure 90 degrees. So they're all going to be all these angles are going to be congruent. So the square is equiangular. Have some problems pronouncing that, but for the rhombus, all the sides are going to be congruent because that's the definition of a rhombus, right? A parallelogram with at least two adjacent congruent sides. But not all angles are going to be congruent, right? And you can see this just by looking at the figure, right? Normally I don't recommend doing that, but do it for this, right? So angle A is larger than angle B. You can just tell by the picture. Like I said, you can always trust your eyes, so I just did it for this example, but at any rate, the rhombus ABCD is not a regular polygon. Okay, the measure of each exterior angle of an n-sided polygon is 360 degrees divided by n. Since an exterior angle is supplementary to an interior angle, each interior angle will measure 180 degrees minus 360 degrees divided by n. So, for example, a 9-sided polygon, each exterior angle will measure 360 degrees divided by 9, or 40 degrees, and each interior angle will measure 180 degrees minus 360 degrees divided by 9. And if you work this out, you get 140 degrees. So if you like to look over exterior angles, I did a more thorough and comprehensive explanation of what it is in my last video, so check out my last video, which is pretty short. And I just want to do some problems right now, so let's just go ahead with this problem. ABCDEFG is a regular polygon that has 7 sides, and we're going to prove that triangle ADE is isosceles. So I write down what I know. I know that ABCDEFG is a regular polygon. That's a given. And we know that all sides of a regular polygon are congruent. So in other words, side AB is congruent to side AC, and side BD is congruent to side CE, right? We also know all the angles of a regular polygon are congruent. So angle B, this angle here, is congruent to angle C. So if we apply side angle side postulate to 2, 4, and 3, we get a triangle ABD. This triangle here is congruent to triangle ACE. And by corresponding parts of congruent triangles are congruent, we know that segment AD is congruent to segment AE. Well, a triangle with 2 congruent sides is isosceles, so we conclude that triangle ADE is isosceles. I'm just going to do one more problem, and that's going to wrap up tonight's tutorial. Pretty short, so this problem is a little bit more difficult. So we're given that ABCDEF is a regular polygon, and we want to prove that BCDE is a rectangle. So remember, most of the time when we try to prove something's a rectangle, we first try to show that it's a parallelogram, right? So that's the path we're going to take in this problem. So I write down what I know. This fact here, And since it's a regular polygon, we know that segment BA is congruent to segment DF, segment AC is congruent to segment FE, and we also know that all angles of a regular polygon are congruent. So we know that angle A is congruent to angle F. We also know that segment BD is congruent to segment CE. So I'm going to apply side angle side postulate to 2, 4, and 3 to get triangle BAC is congruent to triangle DFE. We know by corresponding parts of congruent triangles are congruent that segment BC is congruent to segment DE. We also know that angle ABC, so this angle here, is going to be congruent to angle FDE, this angle here. So remember, when I'm in this particular problem, all the sides are going to be congruent, so it really doesn't matter the ordering so much in the triangles, if that makes sense. I know in a lot of my last videos, I specified the ordering. Here it doesn't really matter so much because these two angles are going to be equal, congruent, and these two sides are going to be congruent. So that's just a side note. So anyway, BCDE is a parallelogram, right? Because we showed that in 5, segment BD is congruent to segment CE, and we showed in statement 7 that side BC is congruent to side DE. And we know a quadrilateral with 2 pairs of congruent opposite sides is a parallelogram. Now we've proved that BCDE is a parallelogram, and now we're gonna prove that it's a rectangle also. So we know that all angles of regular polygon are congruent. So angle B, so this entire angle here, is going to be congruent to angle D, this entire angle here, right? So I'm going to use the subtraction property congruence to statement 10 and statement 8. So we're going to do angle B minus angle ABC is congruent to angle D minus angle FDE. And then by substitution, angle CBD, this angle here, is congruent to angle BDE, this angle here. We also know since BCDE is a parallelogram, side BC is going to be parallel to side DE. So if we take segment BD as a transversal, then angle CBD and angle BDE are going to be consecutive interior angles, right? And since these lines are parallel, they're going to be supplementary, right? So we know that angle CBD is supplementary to angle BDE. And by statement 12 and statement 13, we know that angles that are both congruent and supplementary are right angles. So we conclude that angle CBD and angle BDE are right angles. And we know a parallelogram with at least one right angle is a rectangle. So BCDE is a rectangle, which is what we wanted to prove. So this is a harder problem, so don't feel discouraged. Like I always say, it's a lot of practice, and, always feel free to pause my videos, go over the proofs and just try to work them out on your own, and then go over it, as many times as you need. I try to make sure that all my proofs are detailed, so, a lot of steps you could probably condense, but I want to make sure that all my viewers kind of understand, what's going on behind the logic and the reasoning when I do these problems. So that's all I have for you tonight. I want to thank you for watching my videos, and I hope to see you during my next tutorial. All right, have a good night, everyone. Bye.